So let's continue our talk on the basic properties of all limits. And this is true for any limits in which the limit exists, where we have b and c equal to real numbers and n is some positive integer, and f or g are functions that have these particular limits. That is, specifically, we know that f of x is some limit L as x approaches c, and g of x is some limit k as x approaches c. What must be true? Well, one rule tells us in scalar multiplication that if we take the limit as x approaches c of some constant b times the function f of x, it's exactly the same as taking that constant b times the limit. And we can actually illustrate this with a couple of different problems. Let's say that, for example, I knew that my limit as x approached c of f of x was equal to, well, I don't know, let's make this one 3/2. We don't mind a little fractions between us here. And we'll talk about the limit as x approaches c of g of x. We'll talk about g of x having a limit of 1/2. So g of x and f of x are the kind of functions that have these particular limits as x approaches the number c, whatever c is, right? Then we could say that, for example, if I were to take the limit as x approached c of 4 times f of x, well, if we know that our limit is 3/2, then this is like saying 4 times 3/2. And if we multiply 4 times 3 and divide it by 2, or we divide 4 by 2 and multiply it by 3, either way, we get 6 as that result. All right? We have a sum or difference rule that says that the limit as x approaches c of f of x plus or minus g of x would be the same as the limit L plus or minus the limit k. So, for example, in this case, we could certainly see that if we were to check the limit as x approaches c of our function f of x plus g of x, we know our limit of f of x is 3/2, and we're going to be adding to that the limit of g of x, which is 1/2, and so by this rule our result is going to be 4/2, which is the same thing as saying 2. The limit as x approaches c of f of x times g of x is exactly the same as taking the product of the limit as L times the limit of k. So once again, using a different font here, our limit as x approaches c of the functions f of x times g of x in our example above would really be saying, g of x, pardon me, make that a better g of x here, Professor Peoples. Yes. G of x is going to be the product of our limits 3/2 and 1/2, which is to say 3/4, right? If we multiply these together, 3 times 1 is 3, 2 times 2 is 4 3/4. There we go. Okay. Finally, if we take the limit as x approaches c of f of x over g of x, we take the quotient of these two. That's easy enough to see. Taking the limit as x approaches c of f of x over g of x in this particular example, takes me a second to write this, is going to be the same as if we took 3/2 and divided it by 1/2, which you know to be the same thing as saying, well, that didn't come out very well, which is going to be the same thing as multiplying the numerator by 2. Our limit will be 3. Finally, if we take the limit as x approaches c, let's talk about it this way. The limit as x approaches c of f of x raised to any power is the same thing as that limit raised to that power, again, provided that the limit exists. So if I were to take our original function f of x I tell you I wanted to find the limit of that as the function was squared. It would be the same thing as taking the square of the limit, 3/2, which is to say our limit is 9/4. Not too bad.